welcome students. Today we are going to be covering notes 3.3, proving lines parallel. Suppose two lines in a plane are cut by a transversal. So I'm going to draw two lines. Line 1 and line 2. Cut by this transversal, which I'm going to label as T. Then I'm going to label these as angle 1, angle 2, angle 3, angle 4. Then down here is going to be 5, 6, 7, and 8. Okay, and that we're going to refer to this picture as we fill out this information here. Now, we went over this in the last set of notes, 3.2, so let's just review. The corresponding angles postulate was when you had two parallel lines and they were cut by a transversal. We knew that the corresponding angles were congruent. So here, these could be parallel, but we don't have proof because we don't see the symbols. And I purposely drew them so they didn't look parallel. But it says, if two lines are cut by a transversal so that the corresponding angles are congruent, then we know that the lines are parallel. So here it's backwards. That's what this converse means. So here, if we can prove that angle 1 and angle 3, because those are a pair of corresponding angles, angle 1 is congruent to angle 3, comma, then if I can prove these two are congruent, then I know that these lines are parallel. So line 1 would be parallel to line 2. But only if these are congruent. Okay, and then of course corresponding angles, it could be the 2 and the 4, it could be the 5 and the 7, or it could be the 6 and the 8. Alright. Next, alternate interior angles converse theorem. So again, converse means go backwards, because like the converse statement, we flip it. Same here. If two lines are cut by a transversal, two lines cut by the transversal, so that alternate interior angles are congruent. Alternate interior, here's our interior, so alternate interior would be 2 and 7. So if we can prove that angle 2 is congruent to angle 7, here's my congruent symbol, then I know that line 1 would be parallel to line 2, but only if the alternate interior angles are congruent. Okay, alternate exterior angles converse theorem, so it's flipped again. If two lines are cut by a transversal, two lines cut by the transversal, so that alternate interior angles are congruent. Oops, here's that typo again, alternate exterior angles are congruent, then the lines are parallel. So here, a pair of alternate exterior would be 1 and 7. So if I can prove that angle 1 is congruent to angle 7, then I could prove that line 1 would be parallel to line 2. Alright, finally, consecutive interior angles converse theorem. So that's going to be flipped again. If I have two lines cut by the transversal, so that I can prove that the corresponding consecutive interior angles are supplementary, then the lines are parallel. So if I can prove that angle 6 and angle 7 are supplementary angles, comma, then we would know that line 1 would be parallel to line 2. Okay, so this is your first introduction to converse theorems. So sometimes we have theorems that go one way, and then we'll have the converse, which flips them around. All right, here's an example. If angle 1 is congruent to angle 2, which lines must be parallel. Okay, so if you take a look, the two that we have that we're talking about, angle 1 and 2. So I'm going to mark these 1 and 2. Now again, until I get used to it, I'm going to mark the interior and the exterior. So in the last set of notes, I used orange to mark the interior between the lines. So that would be here and here. And then the outside would be here and here, or it would be here and here. But since I am talking about these two angles, notice how I have one on the inside, one on the outside. So you think about these two right here as being my two slices of bread for my sandwich. So this is going to be the outside, and this is going to be the inside. So which lines must be parallel? That would be A and B. So we write line A is parallel to B. So A and B, you think of A and B as the bread, and you're going to think of D as the toothpick. So I'm going to write that down. A and, this is what you think. Think A and B are the bread of the sandwich, and D is the toothpick, the fancy toothpick holding the sandwich together. So if you turn around, there's your sandwich, there's your bread, there's the inside, and there's your fancy toothpick holding it all together. Okay, next, find the value of x so that A and B are, A is parallel to B. Write a conditional statement. Okay, well, let's see. These are corresponding angles. I want them to be congruent, so that means I want their measures to be the same. So I want this right here, 4x plus 10, I want it equal to 110. Subtract 10 from both sides. That leaves me with 4x on the left equaling 100 on the right. Divide both sides by 4. I get x equals 25. Okay, so what this is telling me is, it says write a conditional statement. If x equals 25, then A must be parallel to B. But that's only when x is 25. If x is any other number, then we know that A and B, they're not parallel. Okay, now next. Over here, we have here's A and B. This is going to be the interior. Here's the exterior. So if I look, then I have both of them are exterior. They're on opposite sides of the toothpick. So this is alternate exterior angles. I want them to be equal because remember they're congruent. Alternate exterior angles congruent. So here I set these equal to each other. So that's going to be 3x minus 50 equal to 2x minus 5. Use my algebra skills. Subtract 2x from both sides. That leaves me with x minus 50 on the left equaling a negative 5 on the right. Add 50 to both sides. That gives me x on the left equaling positive 45 on the right. So the conditional statement that I want to write is if x equals 45, then A is parallel to B. but only when x is equal to 45. If it's equal to any other number, then those won't be parallel. All right, next, if you look down here, again, you need to identify the inside and the outside of the sandwich. So here's the toothpick. So that means that this is the outside of the sandwich. Here's the inside. These are on opposite sides of the toothpick, so that's alternate interior. So alternate interior up here, that means that they are congruent. So I want to set these equal to each other. Okay, so here, 6x plus 12, I want to set that equal to 8x. Use my algebra skills now. I'm going to subtract 6x from both sides. On the left, I'm left with 12, and on the right, I have 2x. So dividing by 2 on both sides, and I get x equals 6. Okay, so now writing my conditional statement, I say, if x equals 6, then A is parallel to B. All right, finally, I have this one here. There's my toothpick. This is my exterior. Here's my interior. Now these are on the same side of the transversal, so those are my consecutive interior angles. So I don't want them to be equal. I want them to be supplementary. And remember, the meaning of supplementary means that the measure of angle 6 plus the measure of angle 7 would equal 180. So I want to add these two together, excuse me, and set them equal to 180. Excuse me, so 6x plus 7 plus 3x plus 38 equals 180. And that is my geometry part of this. Now I use algebra. 9x plus 45 equals 180. Subtract 45 from both sides. I get 9x equals to 135. Divide by 9 on both sides. I get x equals 15. So my statement would be, excuse me, if x equals 15, then A is parallel to B. Okay, folks, I want you to do 7, 8, 9, and 10 by yourself, and I want you to bring those in for your check for understanding. So make sure that you look at this diagram and you bring this in to class so that we can go over it. And that's it.